Greetings, David Stewart here again. We're going to talk about music theory. This is, I believe, part 3 in my music theory series. And what I wanted to do in this video is expand on the ideas of the harmonic or overtone series. Plug in some real numbers to see what they look like in real life, and then use those real numbers and the math that we use to generate those real numbers to basically create a collection of pitches within an octave that we could call a scale or a key. So let's start with our A110. That's just this 5th string ringing open. And if you remember from the previous lesson, all of our harmonic theory is going to have to do with this idea of a complex tone. That as you divide the string length up, you have a series of overtones that pop out, each one getting progressively higher, and each one gets higher by a certain mathematical relationship. Namely, you're multiplying what's called the fundamental frequency. So here we have 110, the fundamental, the lowest frequency of that whole set of frequencies that our brain interprets as a complex tone. And what we're going to do is we're going to be multiplying that 110 basically all the way through to find a whole bunch of different notes and pitches that we can use in combination with that A to create some harmony. So the first one is A110, our trusty 110 hertz open A on our 5th string of our guitar. And first people are like, man, this is 3 videos on one string. It's like, yeah, you got to master that one string. You got to master the knowledge of one thing before you can proceed on to really master a knowledge of many things. So keep that in mind. So our x over 2, remember there's an inverse relationship between the division of the string length or whatever thing is vibrating. Same thing with a trumpet. You divide the length of the vibrating column of air. So there's an inverse relationship between the division of the string length and the frequency that's generated. So the x over 2 value is going to be 220 hertz. Okay? Okay, and we actually, in the Western system, we assign both of those the letter A, although they're A's in what are called 2 different octaves. That's the fundamental, and that's an A, and we call that relationship an octave. Octave for 8, that will become clear later on when we start looking at notation, because when we notate these on a staff, they end up being 8 notes apart, but that doesn't really describe their mathematical relationship. The mathematical relationship between these pitches is one of double. Anytime you have one frequency that's double the frequency of another, that's an octave. Our brain hears that as an octave. It's a very special relationship. And it's sort of the basis for a lot of the math that we're going to do here. So any frequency, if it's double the frequency of a lower frequency, there's an octave space between them, and we can interpret them as the same, what's called pitch class. Remember pitch class, if you want to think of an easy definition for pitch class is basically all the notes that have one letter if you're using a Western system, or all one frequency and all of its octaves above and all of its octaves below. That's a pitch class. It's whatever frequency, all of its octaves above, all of its octaves below. In our Western system, we give them all one letter name. In this case, it is A. Okay, so that relationship of an octave is kind of special, and it will come in here later. Now, the 3x, or the x over 3, is going to be 3 times the frequency. So we just write down here 330 hertz cycles per second. And we don't know what that is, because 440, that's going to be the x over 4. That one's A. And we know that that one's A because it's double the frequency of another A. So as you continue to double the frequency, you're just going to keep getting that same note over and over again. The next one would be 880 hertz. The one above that would be 1760 hertz, which we will get to. And it actually will go on from there. You can keep doubling it to go higher and higher. The space between those octaves gets bigger and bigger because it's about doubling the frequencies over and over again. It's not about just multiplying them, though that's what we're doing to find all our other pitches. What I love about using 110, by the way, besides the fact that we're not having to deal with decimals just yet, is that it's 11, and it's easy to see multiples. You know, when you have 1, 2, 3, 4. So the first one, second one, third one, fourth one. So what we have here is a ratio between these 2 pitches. That's a 3-to-2 ratio, 3 being the bigger one. You can also express it as 2-to-3, depending on which one you want to say is holding the ratio captive. So what that means is that this ratio, you can multiply the bottom frequency by 1.5, and you're going to get the top frequency. So any two frequencies, or you can take any frequency, play a frequency that's 1.5 times faster or higher, and you're going to get this relationship. We call that relationship, just so you know, a fifth. Okay, it's the next. You can think of it as like the next level consonants above octave. Octave, or unison playing the same frequency, that's the most consonant. Octave, doubling the frequency, that's the next. It's really consonant. Fifth is also very, very consonant. That's going to be triple, or a 3 to 2 with the lower frequency. And you can create this with any set of frequencies. Once again, we have an octave here of A. Okay, and what I'm going to do, since I could just tell you what letter that is. I could just tell you that it's an E, which it is. But I'm going to give you the letters towards the end of this video for a very sort of specific reason. And that will become apparent when you go and you do a little research on your own. So what I'm going to call that is the dominant. And I'm going to introduce a couple of terms to you. One is dominant. The other one is tonic. I have way more in store for you. The tonic you can think of as like the main fundamental. The tonic is going to be all the pitches that are multiples of the first fundamental, that's tonic. The dominant is going to be that first new pitch plus all of its octaves, okay? Makes sense, hopefully. Let's keep going. Next one we're going to get is 550 hertz. 550 hertz, I could tell you the name of the letter, but instead what we're going to do is we're going to learn another term. We're going to call this one mediant. Okay, tonic, dominant, mediant. The median is 550 hertz. We have a special relationship right here of 5 above to 4 below, or you could express it as 4 below to 5 above. Doesn't really matter. The point is there's a relationship between those, or you can multiply the lower frequency by 1.25 and you'll get the higher frequency. So if you want to create this relationship, this 5 to 4 tonic to mediant relationship, you multiply the lower frequency by 1.25 and you will get the higher frequency, and you'll get the sound of that particular harmony. Sounds a little bit like this. Okay, and the tonic to dominant sounds like this. All right, next pitch up, 660 hertz. Now, using our essential understanding of what an octave is, we can see that these two are the same. So I'm just going to write a DOM for dominant right there. That's the dominant again. And so what we have right here in this little cluster is we have the tonic, the mediant, and the dominant right in a row. And what that actually makes, just so you guys know, is a major chord. And it actually makes that major chord. Those of you who are guitar players can probably figure out exactly what that major chord is. So it makes a major chord, which is really, really interesting. That means our major chord for the key, and we're going to operate in the key of A. Our major chord's really close to the bottom here. It's really, really close to the fundamental frequency, which means it's going to feel very restful. These relationships are very close and harmonious. Let's keep going though. Okay, next one is 770 hertz. We can quickly check, is this double of anything? It's not double of anything, right? It's not double the median, it's not double this, it's got to be something new. And so what that 770 hertz is actually what we call a subtonic. All right, it's called the subtonic. Subtonic. I'm sorry if my writing's like very small or you can't see it. Subtonic is in below the tonic. And we call it the subtonic because right above that is 880 hertz, which you guessed it is A again. That's the tonic once again. So we've gone tonic, tonic, dominant, tonic, mediant, dominant, subtonic, tonic again. And we're going to keep going from here. So we're not going to stop here. So the next one is 990 hertz. Another great thing about 110 hertz is that you can just keep multiplying it up. Okay. This one is going to be called the supertonic. The supertonic. Okay. Sorry if that's a little hard to read, but there you go. The supertonic. It's above the tonic now. The supertonic. By the way, you're also going to have a relationship right here. Let me point this relationship out. This is a 6 to 5 relationship or 1.2. So if you multiply the lower frequency by 1.2, you're going to get that relationship. And I'll explain sort of what that relationship is. If we don't get to it in this lesson, it'll be in a future lesson that will take all of these ratios and convert them into what are called intervals, and I'll explain some of the limitations of the Western system when thinking about intervals. And of course, this one's going to be, 6 to 7, which is another one. But let's look at this ratio here. This is an 8 or a 9 above to 8 below, right? Or you can multiply it by 1.125, I think. 12 and a half. Yeah, I think that's 12 and a half. So that's going to give you, if you multiply the lower frequency by that should give you the upper frequency, and you'll get that particular relationship. As you can see, we're starting to get more distant, and that relationship's going to be a little bit more dissonant if you have those two notes sounding together. Let's keep going. Next one, 990 plus 110 is 1100. 1100 hertz. We're going to quickly evaluate, is this a double? Yes, it is. It's a double of 550. So what do we get again? We get the median. Awesome. We can skip that one. Next one is 1210 hertz, I believe. And with 1210 hertz, what you're basically going to get, we don't have any doubles. We can see that this one's kind of new. What you're going to get here is called the subdominant. I'm going to do subdom. I don't want to write dominant out again. Subdominant. I'm not being aggressive. I'm being dominant. All right, so that's going to be called the subdominant. The next one up is 1320, and we do a quick evaluation. We're like, oh, it's the dominant again. It's the dominant, and we know it's the dominant because it's double this frequency right here. Now, because I'm starting to run out of space, I'm now going to come back over here. I'm going to come back over here. We're going to keep going up. The next one's going to be 1430, okay, which we're going to call, let's see if it's a double of anything. I don't think this one's a double of anything, so we're going to call it the submediant, and that's because it's a mediant below the tonic, as you will hopefully be able to see. Next one is a 1540. And we're like, what is that? Is that a double of anything? No, it is 770. It's a double of 770. So what is that? That's called the subtonic. I know I'm throwing these crazy words at you. They'll come into clarity a little bit later. Next one is called the leading tone. So we add another 110. We get what's called the leading tone. And that's because it's the closest tone to 1760, which is A, our tonic, once again. And that's all 16 of our first partials written out in numerical form. So we have a big repeat of A, which is our tonic. We have the dominant, we have the mediant, we have the subtonic, we have the supertonic, we have a mediant, we have a subdominant, and we have a leading tone. We have 8 different kinds of pitches that we can operate with here. Now, I explained in the other one that when you're playing with all these intervals that are really spread out, it's difficult to create a melody, because this one we'd be playing with A, that A, that A, this E, this A. We're only right here, you know? Before we get to here, you know, by the time we get up to leading tone, we're playing really, really high on the instrument. And that's not going to sound melodic. We're used to hearing melodies in an octave, and there's a reason that people did them in an octave, because our voice travels within a fairly narrow range. About an octave, most people is what most people speak in. And we do, by the way, speak in perfect intervals. Just a fun little fact: the human voice, if you're speaking, you are singing. And it's a very, very cool thing that you can look into, is notating what pitches people speak at. So what we can do to generate one octave of all of our pitch classes is each of these that is unique. We can use our principle that an octave is always double of a frequency below it, and we can find a lower octave of it just by dividing it in 2. Now, I've gone ahead and I've done most of the math for you, so you won't have to do this, but you can do the math yourself. And if we're going to start down here, maybe we'll start here at the A down here. So we're going to start with 110, and that's going to be our tonic. Okay, we divide our dominant down And we're going to get, actually, I'm just going to give these to you in the order that they increase. Okay, so the next one up is 121.5, and that's going to be the supertonic. And that's just dividing this one down until you get to roughly around the same tonal area as this 110, the same area. So up above here at the very top, we'd have 220, which equals the tonic again. Okay, we're going to keep going from there. We get a 137.5, and that is basically going to be our mediant. We're going to get a 151.25, and that's going to be our subdominant. We're going to get a 165, a little more round number. That's going to be our dominant. We're going to get a 178.75, which is going to equal our submediant. We have two more pitches to go before we can complete and get up to this 220. So to save space, because I've kind of written myself into a corner, I'm going to go ahead and erase that. We're going to get a 192.5, and that's going to be our subtonic. And then we have a 205.25, which is our leading tone. And we have 8 different sets of pitches. And these are, if we turn these into a pitch class, each one of these in this key of A here is going to have all of its octaves intact. So the supertonic would include this 121 pitch as well as all of its multiples, or as well as all of its doubles, all the doubles that exist in it. And if you'll notice, there's 8 pitches. Those of you who already know a little bit about Western theory know that scales usually have 7 pitches. Diatonic scales are usually written as a 7-note sequence, not an 8-note sequence. The thing is that when we create our scales, sometimes we just leave one of them out. And so for a major scale, you usually leave out this subtonic. But it's not left out entirely. If you guys go back and you look at Baroque music, you look at Renaissance music, the subtonic is frequently used. This particular pitch, if you were to make this a C instead of an A, this is a B flat. And traditionally, back in the day, you would do this as C instead of A. You'd do everything on C. So the subtonic is used a lot, and it's used because it avoids a particular ratio with the subdominant. And so if you have a leading tone and a subdominant ringing together, it makes what's called a tritone, which is an extremely dissonant interval. When they're writing polyphony, they like to avoid that interval sticking out like a big sore thumb poking you right in the eye, so they'll use the subtonic instead. And indeed, you could use either one depending on what inflection you wanted to use. Let's give you some note names, shall we? The bottom one here is an A. We already know that. The next one up is a B. The next one is a C sharp. The next one is a D. The next one is an E. We have an F sharp, G, and G sharp at the top. Okay, and from basically the Baroque period onward, we kind of just leave this G out of it. We kind of say we're not really going to use that G and think of it as part of the scale, and instead we think of these 7: A, B, C sharp, D, E, F sharp, and G sharp. What ends up sounding like this. But indeed, you could use that G and make it like an 8-note scale. And that would be very, very reflective of the mathematics behind this. And like I said, sometimes it was used, the subtonic. Those of you who maybe know something about minor scales, a minor scale can have a subtonic or a leading tone. The leading tone is always what's called a half step away. There's a bunch more ratios that I think I want to look at in a different video because I don't want to make this one overly long. But what you get here is you get a major scale built on the tonic of A. And you could build this off of any frequency that you wanted to start with. You could start with any frequency, build an 8-note or 7-note collection of related pitches that are absolute, and tune a piano that way and just avoid the other notes, and you could play perfectly in that key, and it would sound really, really good. Now, for those of you who want to do some research on your own, which I know some of you want to do, I want you to go, and now that you know what these pitches are, and you can translate all these, you know, the subtonic, that's going to be G over here. Go and see if these measurements line up with those pitches. Go look at the piano list of piano key frequencies for what's called equal temperament tuning. I'll put a link in the description for your convenience. And one of the things you'll notice, I'll just let you know, is it's not really going to line up. And that has to do with some sacrifices that are made in most Western music. Not because this doesn't sound good, but because this sounds good, but if you start using the same frequencies to try to make different keys, you start running into some problems, okay? Thank you so much for watching. Hopefully this little bit has been informative for you. I'll let you look at this here and remind you of some of the terms here. Tonic, supertonic, mediant, subdominant, dominant, submediant, subtonic, leading tone. These are the names of the scale degrees that you use to generate any particular melody that you're going to play. And you can transpose this to any key or starting with any fundamental frequency you want, and you're going to end up generating more or less a pitch collection that you can use that's going to sound really, really good when we start creating chords. And just to remind you, we have these three right here. This is A, C sharp, E, A, C sharp, E. That's an A major chord. That's the tonic chord. When we start building chords based off of any of these other ones, we're never going to have as pure a relationship if we're dealing with this pure tuning as we do with this version of the tonic chord. You guys have a great one. Don't forget to check out my websites down below, dvspress.com, davidvstewart.com, and I will see you guys next time. I hope you have a great, great day.